Okay, let's talk about the binomial theorem. We get given two main equations to help us in binomial expansions. The first is there to help us summarize all these patterns we've just discussed. The second helps us find the specific coefficient of a term anywhere in this expansion. But in order to understand how to use these two tools, we first need to know what n is, what r is, and how everything ties together. For this, let's go back to our book analogy and convert all of these mathsy concepts into more familiar ideas. In a book, we obviously have a front cover that shows the book's title. We also have a back cover at the end of the story that also usually shows the title again. In between our two covers, we have a certain number of chapters, each with their own name, which tell us how our story unfolds step by step. From now on, let's call our front cover Chapter 0 and our back cover Chapter N. Now in any book, you usually find characters. Let's say in our book, there are two main characters, A and B. These two characters start at the front of our book and get transported through the chapters all the way to the end. And just like any story, our characters will change from chapter to chapter, evolving with the details of that specific section of the story. As we said at the beginning, books usually have an index, a cheat sheet that tells us exactly where a specific chapter happens in the story and what the name of that chapter is. This allows us to jump straight to that point in the book and dive directly into where our characters are and what context they're in. This is how our two equations work. Our first one tells us the story from start to finish in a neatly summarized way. It starts with the title of the book, Chapter 0, and fleshes out chapter after chapter until reaching the end of the story, its back cover, Chapter N. Let's start tying everything together. We're going to say that the title of our book is n, the same n that is the exponent of our binomial expression. Now, if our book's title is n, then it will have a total of n plus 1 chapters. So here, with an n of 4, our book will have 5 total chapters. Chapter 0, the title page, and chapters 1, 2, 3, and 4, the back cover. In our analogy, each chapter of the book is equivalent to one term of our expanded binomial expression. So when n equals 4, our first term is a to the power 4, and this will be our title page, Chapter 0. The next term is 4a cubed times b, and this will be Chapter 1 of our book. The next is 6a squared b squared, which becomes Chapter 2, and so on. Now, let's call the number of each chapter r. So r is going to allow us to pick whichever chapter we'd like to jump to, just like an index. In the binomial world, r will allow us to pick whichever term we'd like to jump to. This is how we can answer more specific questions without needing to fully expand the entire expression. Let's see how the first equation syncs up with our book and our example where n equals 4. Remember, n is the title of the book, so our overall exponent, and r is the specific position of our chapter or term. And remember, we start counting these chapters from 0. Here is our generic equation. We said this is the one that will neatly summarize all the patterns of the binomial expansion. The only thing we need to keep in mind for each part of the equation is what n is and what r is. Now, the title of our book never changes. From chapter to chapter, start to finish, the title of the book, n, will always remain the same. Here, our book's title is 4, so we can go ahead and plug the number 4 into all the n positions of our equation. When we do this, look at what happens to our exponents for a and b across the storyline. The powers of a go down in their stepwise fashion, and those of b go up, just like we'd seen before. Character A starts off at the title page and evolves from chapter to chapter and disappears by the time we reach the back cover of the book. Character B appears in Chapter 1 and keeps growing as the story unfolds, eventually ending up all by itself at the end. Okay, so what about our R values? We said the R values are just the chapter numbers, or in the binomial world, the position of our term within the overall expansion. Let's go ahead and complete this equation. We know our title page is in the 0th position, so its R will be 0. Chapter 1 is literally the first chapter, so its R will be 1. Chapter 2's will be 2, and so on. Now that we've done that, we can see that our A and B values and their exponents are complete. They look just like they're supposed to in our final expansion. We've faithfully told A and B's individual storylines from start to finish, with A going from A to the power 4 all the way to A to the power 0, and B starting from 0 and going up to an exponent of 4. But how do we end up creating our coefficients? 1, 4, 6, 4, and 1. Let's take a closer look at chapter 1 of our book. How does this 4c1 a cubed b become 4a cubed b? Looking at it this way, we can clearly see that our coefficient gets created from this NCR portion of the equation. This is where our second equation comes in, the one we can think of as our index, as it will tell us the name or coefficient of our chapter. All we need to give this index is the title of the book, N, and the position of the chapter we're looking for, R. So if R is the number of our chapter, NCR is the chapter's actual name, essentially the coefficient of the term. Here, when N is 4, and we're looking specifically into chapter 1, where R is 1, we can plug those values in and calculate, and see that we end up with our coefficient of 4. Sometimes you'll see NCR written vertically with brackets, but don't let that confuse you. Both of these notations mean the exact same thing. This alternative notation is often quicker to write when drafting out the skeleton of a long expansion to see what the coefficients will become across our storyline. So it's a good version to use in exams. So any term of our expanded binomial can be written in this form, where n is the exponent of the overall binomial, which remains constant from term to term, and r is the position this term has in the storyline, so chapter 1, 2, etc. And if we identify the position of the A or B term the question is asking us about, we just need to use the right value for R to identify which chapter of our storyline we're interested in. We can then use our formula to produce the coefficient for that term without needing to worry about expanding and calculating any other ones before or after. Here's the good news. You can use these two equations to speed up any binomial theorem question. So let's come up with a foolproof plan to get started anytime they give us a binomial and proceed to ask different questions on it. When we get given a binomial expansion, as we do here with 2 plus x to the power 8, we should always begin by defining our a, b, and n values to get our bearings. From there, we can immediately see we'll have a total of 9 terms or chapters in our expansion, and we can write this out in shorthand form very easily. By doing this, we're not actually expanding the binomial, but summarizing what each chapter will be and what versions of our two numbers exist in each chapter. This approach allows us to have a bird's eye view of the entire operation and enables us to answer questions like, find the coefficient of the x to the power 5 term. Here we can quickly see that our x to the 5 term takes place during the 5th chapter of our storyline. And just like an index for a book, we can easily jump straight to that part of our binomial expansion story and begin calculating our coefficient. Once we've calculated using n equals 8 and r equals 5, we can call this 56 our raw coefficient. Be careful, this is not the final coefficient the x to the power 5 term will have, because our other number in the binomial is 2. In this part of the storyline, this 2 is being elevated to the power of 3, so it becomes 8, and we need to factor this in with the 56. This way, we go from a raw to a fully processed final coefficient of 448, and this is our final answer. So in summary, we can think of binomial expansions like the chapters of a book, where our terms are the chapters from 0 to n, our raw coefficients give us the names of those chapters, Our chosen R value allows us to identify the position of those coefficients in the overall expansion, and our N is the title of the overall story, to be used for the front and back covers, i.e. the first and last terms. Our first equation allows us to quickly draft an overview of the whole storyline or expansion, so that we can have the immediate visibility to hone in on whichever chapter the question wants us to focus on. And we know which chapter this will be by looking at what version of our characters, A or B, they want. Basically, by looking at what exponent of A or B they want. Once this chapter is located, we can use our second equation to reveal the raw coefficient and eventually combine it with any remaining numbers into the full answer. For more resources just like this, head over to ms-tutoring.com. And as always, thanks for watching.